Hello, hello. Welcome to the stream. OBS and YouTube are freaking out at the like sending bitrate that's happening. I've been spending the last 10 minutes like, what's going on? Why is my internet being so slow? So let me know if the stream is like really choppy. Because I usually don't have a bitrate this low. Anyway, thank you everyone. Thanks for coming. Looks like I got a bunch of eyeballs today. Of course, I don't know who's watching unless you say something, so please say what up in chat. Hey, Andy K. Let me know that you're out there. Let me know that I'm not just talking to a corner of my office. So, the way that I usually like to start our streams is by doing a little bit of playtesting of the released version of Retro Tank Party, which is the game that we are working on. We're not going to be directly working on it today, I don't think, because we're just going to be writing physics code. Hey, Ricardo! Okay, video's lagging. All right. Hey, Ross. Yeah, Ross says webcam is choppy. I don't know what's going on. I don't know. Hopefully it's bearable. Hey, Mint Arcade. Yeah, sorry about the choppiness. Hopefully it'll even out. Best I can tell, it's the internet being slow. Like, nothing is running on my computer. The load is decent, but computers, technology. Let's all move to the woods and raise llamas like Jeff Minter. Is that the guy, the famous video game designer who lives on a llama farm? All right, so I am going to put the link to the game on itch. No, that's not the one. Firefox letting me down. Retro Tank Party. There we go. So you can play the web version or the download. It's pay what you want. You could want to pay nothing. That is fine with me. I'll put the match ID in chat as well. And then while I'm waiting for people to join, I'll talk a little bit about what I worked on since the last stream. So, for those who watched the last stream, we were working on trying to improve the way that our rollback netcode dealt with latency and packet loss. And we were doing that by creating a new little demo, which used UDP and just did a single client and a single server to do peer-to-peer. We got it working on the stream. And we started to try and make some of the changes that I wanted to make to improve how it dealt with latency and packet loss, but didn't get very far. Since then, I managed to implement all of the things that I was talking about on last stream. Specifically, I wanted to make it so that our rollback code would stop and try to resync for a short period of time before just giving up. Before, if it like couldn't keep the peers synchronized enough, it'd just be, you know, synchronization lost and give up. And sending a mix of old and new messages. I think that's what I was drawing in this picture. Before we were sending, I think, only new messages. When things got out of sync, that would be a problem because they would be waiting on the old messages and it would all fall apart. So then I set it up to send like a little bit of new, a little bit of old. And with those changes and some bug fixes, I managed to get this UDP demo able to handle 500 millisecond latency, which means essentially a 600 millisecond ping and 10% packet loss, and it wouldn't lose synchronization, which was super cool. Let's see who's in here. Oh, we got Ross. Anyone else going to jump on? I know that Ricardo, Sir Tanks a lot, is a frequent player on the streams. Well, I'll talk for another minute or so about what I did since last time, because I did a lot. So got that working here in the UDP example. I moved it over to Retro Tank Party, and it did not fare quite as well with latency and packet loss, but especially packet loss. So I spent a ton of time working on that. I managed to get it to the point where, with latency, Retro Tank Party would perform exactly as I expected. You know, I'd see the right amount of predicted frames and everything, but like even the little bit, just the littlest bit of packet loss, and the whole thing would just fall apart. And I think it's something to do with Webrtc, which is a much more complicated protocol than just working over UDP. And I was able to tune the numbers and really like squish around a bunch of things and implement some other features that got it so that it could handle up to 200 millisecond latency, which is 400 millisecond ping, and 2.5% packet loss, which I deemed good enough to move on. I think the Webrtc issues are solvable. I just, need to take a break from that and do some other things before digging too deeply back into, and data going over the wire and all of that. Andy K can't paste. Seriously? Paste problems? Chrome usually works for me, guys. I don't know. Like, it's so weird. Like, sometimes copy and paste things are working and sometimes they're not. Andy K, if you can, just grab the download. There's Windows, Linux, Mac versions. I think this is probably good for doing a quick play test of the working game. Oh, Andy K is getting in! Huzzah! Connecting! Will it connect? It's not connecting. Oh, geez. If my internet is bad for the stream, it's probably not great for the game either. Yeah, connecting. So what that means is it's trying to establish the Webrtc connection and is failing. Andy K, are you getting connecting for everyone or just me? Because that would know if it's some connection problem between you and I. Something to try is exiting out, going to settings, and there's a network relay. Hey, Zero Wolf, thanks for coming to the stream. Paste issue in Brave browser. Yeah, so there is like an issue with copy and paste with Godot's HTML5 export in some browsers. Usually it works for me in Chrome, and usually it doesn't work for me in Firefox. I had someone say that it worked in Brave for them when we were doing some playtesting in the middle of the week. So it's interesting that it's not working now. I don't know. Anyway, Andy K, if you exit out, go to settings and go to network relay. Oh, it says connected for you. Oh, now you're out. Well, if you go to settings and change network relay, it should be by default on auto, but try switching it to forced or disabled. But try forced first, and then try reconnecting and see if that will let you get in. And if not, I think 3 people for testing the released 1.1 version of the game is good. I also would like to test the current version of the rollback one to see how that deals with the internet latency, especially with you, Ricardo, with Sir Tanks a lot here, because I know that you have a lot of latency on your connection. I'd love to see if it holds up to the real world conditions between me and you. Hey, Zero Wolf is trying to get in. Connecting. Still connecting. Jeez, guys. The internet hates me today. This is what I get for working on an online multiplayer game. Yeah, Zero Wolf, same advice I was given to Andy K. You could try exiting out, going to settings, changing the network relay setting. Yeah, Andy K, it's not going to let you in because the match is full now. It's got 4 people in it, and the max is set to 4. Or, I mean, maybe Zero Wolf just drop out for this one, and I'll play with Ross and Tanks a lot to set a little baseline of how the working game looks, and then we can try again to get everyone connected for the rollback edition to test latency and stuff. Unfortunately, I don't have a button to kick you out, Zero Wolf, so you are going to have to willfully disconnect so that we can try and start the match. All right, we'll do a quick one. We'll do a Battle Royale race to 2. All right, where are you guys at? It's been a while since I've tanked in a non-totally buggy version of this game. Okay. Need some power-ups here. I always regret picking this stage whenever we're playing on stream because there's not very many power-ups in it. Health. Ooh, what did Ross get? I'm scared of Ross. Ross got something. Let's see what it was, though. All right. Ooh, Andy K has left. I didn't know Andy K was in. Some residual piece of your connection was still there, Andy K. Or possibly you were trying to connect when the match was already going. Health. We're going to just have to do this old school. I have no good power-up. I don't know if you have a good power... Oh, you have that. It's going to be hard to take you out if you can just zap away at any moment. There you are. Ha! Victorious! All right. Let's see if I can get one more win and close it out real fast. Maybe, maybe not! Oh god, you guys are cornering me. Ganging up on the person ahead. Probably a good strategy. Power-ups, power-ups. I don't know if it was worth going for that since he just shot me right away. Whoa, whoa! Ross is invisible! Ross, you're getting all the good power-ups, man. I just need like one hit to kill me. I'm not going down that easy. Ooh, power up. Health. Haven't got rid of me yet. Oh crap. Woo! Oh, Ross got a second before I got him. Well played, sir. Well played. Uh-oh, are we getting locked up? No. So this doesn't look good when this is like the released version of the game and it's having this many problems. Ah! All right. I didn't want to spend too much time on this anyway, so maybe best that we switch to the rollback version because I really want to see how it works with real internet conditions. Let's exit out of here. I'll send you guys the link. I'm gonna open Chrome because of course like everyone's having the copy and paste problem, which I also have a feeling that the copy and paste problem happens more with itch than it does not with itch. So I'd be interested to see how this works for you guys. Okay, so here's the... Woo! Okay, sorry about that. Here, we'll just turn the music all the way off, in fact. All right. Oh, on Ross's screen it says I won? Interesting. The winning should be determined by the host. It shouldn't vary like that. Interesting. Maybe the release version of the game could have used a little bit more testing before I made that update, perhaps. All right, so the link that I just put in chat is to the rollback version. The game isn't like fully ported, so ability power-ups don't work. The railgun doesn't exactly work. It gets really crazy. It just sort of like moves infinitely and acts very strange. But it has all of the latest latency and packet loss stuff, and I really want to see how this works. Ricardo, I hope you're able to get in there. I want to try this with because you're in Germany, right, Ricardo? That would be a nice test. So again, while we are waiting, I'll talk a little bit more about some of the other stuff that I did, which you will be able to experience actually when we play this. So like I said, I got the latency and packet loss decent with the Webrtc version. Some of the things that I did to make that happen was I made it so that you could have a special serializer. My screen visually it looked like my tank exploded, but the scoreboard it did show me winning the match. Yeah, thanks for saying, Ross. I mean, I saw you explode too. I just saw me explode slightly before you exploded. Andy K with 150 millisecond ping approximately. So that's pretty good. So yeah, things I implemented. I'll try to get it out there quick. I implemented the ability to add a custom serializer for your game. I can bring that up actually. We are streaming after all. I can show things. And made it so that it's now sending not these dictionaries serialized using Godot's default binary serialization of dictionaries. It's using a custom serialization thing that I just made up. I just said serialize this byte and then this byte and then this byte. I'll show you the code for that. It is in source autoload network sync. So yeah, we are just like writing a single byte to represent which thing this is input for. This single byte is like or not single byte, this 4 bytes is like a checksum. Anyway, it's just byte packing here, and it's got it so that the largest the messages can actually get is 135 bytes, which really helped. It's strange, but it totally helped. I set up this thing you could swap in a special network adapter so that the Webrtc version doesn't go through Godot's RPC system. It goes directly to a data channel on Webrtc, which saves more bytes and gives us more control. I added interpolation. It's only interpolating a single frame, so it simulates the frame, then it rolls back to the previous frame, and then interpolates between them. So I was able to actually reduce the frame rate of the simulation from 60 frames a second to 30 frames a second, but keep the rendering at 60 frames a second, and you really can't tell the difference, because it's still rendering 60 frames, it's only simulating 30 and interpolating the in-between one. And I set up a thing to prevent overprediction in the case of really high latency. And let's see who's in here. Whoa, thanks a lot. That is some serious latency. Holy cow. A ping of 1.2 milliseconds? We were just playing. Like, oh, awesome. Thank you, Mint Arcade, for recording yours, because I would love to see how it looks. Whoa, thanks a lot's ping just dropped dramatically. That's a nice ping. Let's see if it stays there. I'm kind of afraid, guys. All right, let's do a similar battle royale setup. I'm gonna do desert because there's more power-ups, even though most of the power-ups don't work, but whatever. Let's see how this goes. Where's everybody at? Ooh, hey, Andy K, looking beautiful. I am not seeing any rubber banding. That looks fantastic. Where is Ricardo? There's Ross. Ross ain't doing nothing. All right. Maybe he had to step away. Thanks a lot. You just chilling? Thanks a lot. And Ross, what are you guys seeing on your end? Do you guys just step away, or is something catastrophically failing? Well, Andy K, your synchronization looks beautiful. Oh, I totally did not hit that, and the box opened. And the power-up's not working. Last time I was testing this, the spread power-up did work. Is Ricardo? Ooh, tracers are working. What's going on, Ricardo? I don't know. Let's kill. Oh, I'm not touching that railgun. Let's kill everyone and start over and see if that somehow helps or hurts. We'll see. Kill me, Andy K. Or I'll kill you. Either way. Ooh, now we're losing synchronization. Oh, everything's going to hell now. Ricardo won on... Oh, interesting. I'm driving around firing and seeing other people driving around firing. It looks fine on this end. Interesting. I've never seen that particular issue. Let's see what happens. We might have to start a new match code. So Ross still is stuck on my screen. What in the heck is happening? Ricardo won on his end. Let's start over, guys. Obviously, the game is buggy because I haven't fully ported it to rollback, but I just really want to see the latency. I want to see the latency. That is so weird. There is like this possibility with Webrtc of the mesh splitting. So with peer-to-peer games, you know, like using Webrtc, there's an independent connection between each of the peers, and there is a thing that can happen where like two peers remain connected and this other group of two peers remain connected, but there are no connections between them. There should be code in the game that tries to prevent this. We should be able to see, well, I'm going to make a note about this because obviously whatever I'm doing is not working well enough. And this is a theoretical problem that has existed for a while, so playtesting notes. Mesh split. Let's try this again, guys. The main point is I want to see how it reacts to latency. I want to see how bad the rubber banding is. The interpolation and the reduced frame rate and the attempts to prevent overprediction all should have reduced rubber banding, even in like really extreme cases. And I want to see it. Yeah, Ross is an even lower ping to me. Ricardo, you got to get in there, man. You got to get in there. Or somebody who's like really far away. I'm in the Midwest of the United States. Someone who's got some distance. Get in there. I want to see how the game works. Yaroslav, that sounds like someone who's far away. Let's do this. Your ping isn't that high though. Out of curiosity, where are you? Oh no! Oh. Oh, okay, cool. So the thing that I added to not totally lose sync immediately kicked in and saved us there. Sweet. Yaroslav, you are working well. Out of curiosity, please let me know where you're located, Yaroslav. Oh, this is looking beautiful! I am seeing... Ooh, other than this attempting to gain resync... We lost sync. It was looking great though in Moscow. Privyet. All right. Let's just try it. Let's just try one more, especially if Ricardo can get in there, and then we'll get down to hacking. You know, okay. So I'm happy that. The attempting to gain resync thing kicked in and then got us back on track, which is awesome. I'm unhappy that we ended up totally losing sync at the end. Oh, cool. Andy K recorded the last match and there was almost no rubber banding, but lag is bad? Interesting. So what exactly do you mean by lag, Andy K? Because it should be showing the same things on the same frame numbers, and when it isn't, you should see rubber banding to correct it. So, yeah, I guess since you recorded it, I can totally see what you saw. So let's on Discord later, we'll figure out how to get your recording over to me. Ricardo, you still out there? Yaroslav? Thanks a lot. Sweet. All right, I just want to watch for a second and see what the latency is. It's not so bad right now. It's not that like 1 second latency. All right, all you guys probably are much closer to each other than you are to me. So let's see what happens here. Ooh, ooh, ooh. Oh, okay, it kicked in. I was scared for a second. Oh, thanks a lot. I am seeing 0 rubber banding. Where's our tovarish iz Moskvy? Yaroslav, damn, that's looking good. Oh no! Attempting to gain resync! Attempting to gain resync! Are we gonna lose it? Synchronization lost. Oh, okay, so what does that mean? If the rubber banding was not present, that means that the interpolation, frame rate change, overprediction stuff, that all worked. The fact that we were losing synchronization, I wish I knew why we were losing synchronization. Can I see from developer tools? What am I looking for? I'm looking for developer tools. There we go. See if it says in the console, because it theoretically should. I mean, I'm printing that crap, but on the web, everything's always a little sketchy. Sync lost. What do we got here? So we have the pings. Some pings. What is this message? Oh, here we go. Attempting to retire input frame. Okay, so that's actually what I should be looking for. I just wasn't expecting to be red. Okay. Synchronization lost. Okay, so attempting to restore this state, but 794 was still missing input. So peer number 4, which I believe was Ricardo, was tanks a lot, was still waiting for a particular input, or no, we were still waiting for a particular input frame from him, and weren't getting it. And I think I have it configured to wait 5 seconds. And while it's waiting, Ricardo's client should be sending over and over and over again all of his newest and oldest state. Wow, okay, so we were maxing out the state buffer. I wonder if that's just packet loss again, messing with us. Because if Ricardo's client is sending the oldest and newest state over and over again over this 5 seconds, and I'm just sitting here waiting for the same bit of state, or same bit of input. I keep saying state when I mean input, because like scrolling up here, it's always this input frame 794. Interesting. So not a perfect test, not a perfect test, but it's looking way better than it did last week. For sure, it's looking way better than it did last week. So I think we still need to worry about packet loss. I also wonder too, like, I don't have a spectator mode implemented yet. I really want to get a spectator mode implemented, but I wonder if you guys, if you three all played together on your own, if it would work better than having me in the mix, because I believe so Ricardo is Germany, Andy K is UK, and Yaroslav is in Russia. So like you guys are all at least on the same continent. I would love to see if that worked better, because it is peer-to-peer. Like without connecting to me, you guys would just, your traffic would never leave that continent. Well, thanks so much, guys. Thanks so much for testing. Let's move on from latency and packet loss thinking. I will definitely see what I can cook up for next week, maybe improve on that situation. And let's start to think about physics. We're here to work on physics today. Ooh, Yaroslav is throwing out a match ID. If you guys could play a match, yeah, do it. Do it, guys. Do it. Oh, Mid Arcade's throwing out one. You guys are gonna have to decide who's gonna lead here, who's in charge. I'll get my windows arranged here while you guys are playing. Get my sketch pad ready to talk about some fixed point mathematics. Yeah, ooh, I am really curious to see how it goes for you guys. And so that, you know, the other eyeballs who are watching, by the way, welcome to all the people who joined the stream. There's quite a few more eyeballs than when we started. Please say hello in the chat. If you don't say hello, I don't know who's there. I don't know who's watching, and I'd love to know who is out there. And if you've got a project you're doing in Godot, please, you know, give a little description of it. I love to hear what everyone's doing. So what we're going to be working on today, I will get started telling you guys about that while those other guys are playing a little match. We are going to be attempting to implement very simple deterministic network physics to go in Retro Tank Party. And physics might be a little bit of over description. We're going to be essentially just implementing collision. I think at some point it would be interesting to add real like rigid body physics to it. Because if this works, if this network synchronization technique works for Retro Tank Party, I may port it over to Fish Game, which is a demo game that I made for Heroic Labs. Also like a 4-player multiplayer thing with the Nakama server. And it could really use some rigid body physics for like throwing the weapons. Yaroslav won the match. So yeah, we're going to be trying to implement very simple network physics. I decided to go with fixed point math. There's basically 2 challenges in doing deterministic physics. One is making sure that your math isn't random at all. Some physics engines actually purposefully put randomness into them because it can help with stabilizing jittery objects. So you have to not do that for network physics. And then also floating point math. Floating point math on different machines, on different architectures, on different operating systems will yield subtly different results. Particularly if you're calling like math functions from the operating system, like to calculate cosine or sine or whatever, those can be done in very different ways, depending on whether you're on Windows or Linux or Mac or whatever. So one of the solutions is fixed point math. The other is soft floats. I'll talk about both of those and then tell you why I chose fixed point math. So fixed point basically works like you have a binary number. Here, we'll just draw 8 bits. You don't have to watch me draw a lot of circles here. And you pick an arbitrary number of bits to be the fractional part. And that's really it. Then you deal with your number as integers. Addition and subtraction of fixed point numbers works exactly the same as addition and subtraction of integers. Multiplication and division are a little more complicated. When you multiply two fixed point numbers together, it moves the decimal place over by the same size as, like it doubles it. So if you had 4 bits, it would become 8 bits. And so then after multiplication, you need to shift backwards. And a division is similar. Dividing will remove bits of decimal bits, I guess we'll call them fractional bits. Fractional bits is probably the most accurate. So you have to shift the first item that you're dividing first to the left and then to do the division. Another alternative, like I mentioned, is soft floats. So rather than trusting the processor, which has its FPU to do the floating point math, which can turn out different on different processors, rather than trusting the OS math functions, you just implement all of that in software. And that will also yield determinism. I ended up choosing not to go with that for like maybe 2 or 3 reasons. One is that I'm familiar with fixed point math. I've done fixed point math in a lot of different circumstances, including in assembly for the 65CO2 processor. But also, it's easier to deal with literals, at least I think so. I guess I didn't dig too deeply in how I would deal with literals in soft floats, but because they're just integers, like if I want to make a literal number 1 in fixed point math, I can just put an integer that is the literal number 1. So specifically, I've decided to do 10 bits for the fractional portion and using 32-bit integers, so the remaining 21 bits for the number and then the top bit for the sign. So 10 bits of precision is nice because that means your fractional amounts go down to 1/1024th, which is almost the same as 1/1000th, which is like thinking of 3 decimal places. So I can sort of imagine in my human brain, which doesn't deal very well with binary numbers, that we kind of go to that level of precision. So anyway, if I want to put a literal number 1 in my code, that's 1024. So it's really easy to deal with literals. Also, the primitive value is also very simple. It's an integer. When I was trying to integrate the fixed point math stuff into Godot, it was very frustrating in that I can't add new primitive types to Godot. I can only add new classes. And so if I were to make a soft float, it would be a soft float class. And then I'd always be dealing with this soft float class, which means it's allocated on the heap, which means it has all of the junk that goes along with the Godot object, which is like signals, reference counting, all of that stuff, when I just want a primitive value. Let me see what's going on in chat here. Yaroslav, nice win. Now he won. For us, it works okay. Yes, nice. 2 people almost like playing on a LAN. Awesome. So I was the weak link. That's actually great, to be honest. It's a peer-to-peer game. If you are playing with someone who has a really high ping, like kinda maybe don't play with them, right? Like that sounds bad, but you know, it's a network game. You want it to be a smooth experience. It's still like, it's frustrating that playing together with you guys, there was no rubber banding, which leads me to believe that we should be able to make it work. And the latencies weren't that high, right? Like the ping numbers were like 150 to 200 milliseconds. So theoretically, that should work. We shouldn't have lost sync. And I'm guessing the reason that we lost sync is this mysterious WebRTC not dealing with packet loss very well problem, which I got to dig into. And here, let's take a slight detour on WebRTC and packet loss. So the UDP version works like amazing, and that's because, well, I don't know if that's because, but the stack is just so much simpler on UDP. So we have RTP's code, the code I wrote, and then underneath that is Godot's, we'll just say grpc system, which packages up the data, like puts in a node path, the function we're calling, some whatever packaging stuff. Then underneath that we have enet, which is a library that's basically doing kind of like our transport protocol. It's splitting up these RPC messages into packets and implementing its own kind of reliability and ordering and whatever. We're asking it to do completely unreliable. So in our case, it's just like throwing the data into UDP packets. And then underneath we have UDP. So this stack is like really simple. And everything I do to the UDP version like acts exactly as I would expect it to. In the WebRTC version, the stack is much more complicated. We have the grpc layer here, theoretically, although I actually removed it because I implemented that network adapter thing where you could just talk directly to WebRTC. And then we have the Google implementation of WebRTC, or I guess in the desktop version we have the Google implementation. This is either Google or the browser, right? Writing with a mouse, beautiful. And then underneath that we have a transport protocol called CSTP, which similar to enet, breaks up the message that we give it into individual packets, implements its own kind of reliability, whatever. And then rather than going straight to UDP, we have DTLS, which adds SSL on top of UDP. So this is kind of like the HTTPS of UDP. And then we have UDP. So we have all of these layers that are different here. And something in there is responding really badly to packet loss. And I tried a bunch of things that haven't worked yet. But one idea I had was like, well, we're losing some packets, so send more packets. I added some code that like in between the simulation frames would send additional like duplicate packets with the idea like, well, if we're losing some of them, we'll send some extra ones. And if we do it on the in-between frames, like it shouldn't clog up the connection, right? Like because we reduced from 60 frames a second to 30 frames a second, and maybe on that in-between frame, just send some extra data. That did not work. For whatever reason, it actually made things way worse. I've done a lot of stuff with making the packets smaller, with making the packets bigger. I've been wondering if the this part is doing some kind of buffering that I'm not aware of. And of course, like the Google implementation, I have the code. I can look through the code and try and figure out what it's doing. But something in there, man, something. And I'm determined to find it eventually. Oh, sweet. Thanks, Andy K, for recording all those matches. I'm sure it will be super helpful. You have no idea like the difference from someone describing a thing to being able to actually look at a thing. Like it's super helpful. All right. Hopefully that detour was interesting. Back to what we are doing with math here. I think I covered this, what our fixed point numbers look like. And we're implementing our little bit of physics or collision code, whatever you want to call it, in C++ as a Godot module. I can show you how that looks at the moment from inside the engine. Let's just compile and run what I have. I hope I didn't like make a change and break it last minute like last night or something. Let me just get a terminal open to the game. Why are you not giving me the output? VS Code, very frustrating. So this should be starting up my custom compiled version of the engine with the physics engine changes. You'll see that it's running super slow. That's because it's compiled with debug symbols, so I can run it through the debugger and get a stack trace for when inevitably I screw up my memory management. Okay, so here is this little fixed point test scene that I made. To show you how this works. So I added this singleton SG fixed, which can convert from floating point numbers and back. It's taking the number 2.4 and printing it out. Here, I'll just run that so you can see it. And a window will open and then immediately close. So you can see it's taking the number 2.4, turning it to this fixed point integer value, and then turning it back to a float, which actually ends up as this, because apparently we don't have enough bits of precision to actually represent 2.4. Our approximation of 2.4 turns out to be this value. It can also convert to and from ints, which will not be lossy, as you can see here. 2 becomes 2048, which of course, because we're using 10 bits of precision, is 1024 times 2. And we added some multiplication and division functions, which you have to call like this, because multiplying and dividing fixed point numbers is not the same as multiplying integers. But you can see I did it one time with fixed point numbers and one time with floating point numbers, and we got the same result down here for that. I also added a vector type, which I'll talk about this a little bit later, I think. But it really frustrates me that I have to create a vector type for this because my vector type is a class rather than a primitive value, which means it comes with all the baggage of classes like I was talking about before. But that's because Godot does not give us an integer-based vector type, at least in Godot 3. In Godot 4, there's going to be vector2i, which will be an integer-based vector type, which will be a primitive. And so then I won't need this special vector type anymore. We'll just use that one. But for now we have to, so this creates a vector type, and then because there are no overload operators in GDScript, we have to add and subtract and multiply things with these like special add whatever functions, and you can see it does this little bit of vector math, and there we go. So super basic floating point, or I'm sorry, fixed point math that I've implemented before the stream. I've only done a little bit before the stream, guys. I was just trying to do kind of like boilerplate stuff. There's no actual physics in here. We will be doing the physics. What's going on in chat here? Hey Slacks, welcome to the stream. Ross, might be if we just send packets without some sort of flow control, we risk flooding the connection and inducing severe latency. 2 seconds plus as routers between us and the other computer. Is that a quote from our friend Gaffer on Games, Ross? But yeah, the thing is, I was thinking about this, like, because I don't think, at least in my tests, that I'm flooding the connection, because all of the packet loss that I'm adding in my tests is artificial, and so if you experience latency in real life, like I could totally see that being related to flooding the connection, and then some routers dropping the excess packets. But in these artificial situations, like the packet loss is artificial, so I don't know. But yeah, I have a feeling that some kind of flow control is probably the answer, but I just don't know what exactly it should do. Sending less data can't be the total answer, right? Because we're losing synchronization because we're waiting for an input frame that we're never receiving. So we can't like stop sending and expect the data to somehow get there. Do we like send half as often? Do I make the packets even smaller? I mean, I have them down to 135 bytes. Do I make that even smaller? And then I don't know. There's something here, some sort of mix of voodoo that I think will eventually make it work. Oh, Slacks, you're also working on implementing your own physics. Let's close this up. All right, so let's look at some of the C++ code. Oh, no, wait, there's one more thing I want to show you in the Godot editor first. I also started working on integrating some nodes. Kind of the way that I want this to work is I want to make like our own set of physicsy nodes, like our own area 2D, our own kinematic body 2D, our own static body 2D, our own collision shape 2D, to sort of kind of mimic the Godot built-in stuff. And I also want to make it so that we can edit the shapes in the editor. We're obviously not going to implement all of the features of the built-in Godot physics engine, but I want to be able to easily kind of convert my existing game to this new physics. So having kind of analogs, I can just swap. And of course, I still want to be able to edit the shapes here. So I haven't fully got that set up. Right now, you have to like type in the values manually, but it will, reflect it in the editor. I started working on a editor plugin to like put the handles on there so you can click and drag it, but I haven't finished it. I just kind of like put the boilerplate in there. But you can see that if you look at the ruler here, this is coming out to 50 and 50, negative 50. So these extent values are actually 50, but here's their number, here's the value represented as an integer. So that makes me feel good that I can see the fixed point values there. This being able to view my custom vector type in the editor required making an editor plugin to actually put this control here. So what I think I'm going to do in the end, but I haven't done yet, is have it so that you're actually entering these numbers as like floating point values. So I'd actually type like 50.0 here, and have it just translate to the fixed point value underneath, and then save the fixed point value in the scene. But there's no reason that we have to look at the fixed point value. We can make that easier to use. So anyway, that is all the stuff in the editor. Let's look at some C++ code. Zero Wolf, is making a multiplayer game using Godot's physics even possible at this point? Yes, it is 100% possible to make a multiplayer game using Godot's current physics. It depends on how you are doing your network synchronization. So in the version, in the released version of Retro Tank Party that we played earlier, it's using Godot's physics engine. But it's not doing rollback and prediction. It's doing like this really naive state sending technique, if you can even call it a technique. Basically, it's periodically sending the state of each client's player to all of the other players. And they're just like saying, okay, that's where you are, and sticking it into the game, which means that all of the physics stuff, all of the collision for an individual player is being done on their client and then sent out to the other clients, and they just like believe it, right? So we don't need to have deterministic physics because we're really only doing the physics for each player separately on their own machines. If you're doing a client-server based thing where the clients are sending the data to the server that's possibly validating it and then aggregating it and sending it back out to the other clients, the server could be the one doing all of the physics. And then the physics is only being done in one place, and it doesn't need to be deterministic. So depending on how you're doing network synchronization, having non-deterministic physics is totally fine. Because we're doing rollback and prediction, we need the physics to be deterministic because we are sending only the inputs from each client to each other, and then they are doing the all of the movement and collision and physics calculations independently on each client. And if one of them is different, even subtly different, like even if it's like 0.0001 different, over time those differences can build up to a point where one client you'd shoot someone and see a hit, and another client you'd shoot someone and see a miss. And that would be catastrophic for this particular networking technique. So yeah, you totally can make a multiplayer game using Godot's current physics, just not using this synchronization technique. So I've been making this Godot module. I've called it SG Physics 2D, SG for Snowpack Games. I've prepended everything with SG. The math part, let's look at that first. How do I close this? There we go. Then that will hopefully work better next time. All right. So I have this simple struct for holding our fixed point values. Some constants saying 10 bits of precision, and then just doing like super basic fixed point math here. It's not fully implemented. It has addition, subtraction, division, and apparently the less than and equal than operator, because that's all I needed to do. At some point, this will get filled out with all math operations, all comparisons, but so far, very simple. I made this internal vector. This is not a Godot object. It's basically just a plain struct so that we could put all of our mathy fixed point vector stuff here, and then this rect2, also an internal one. Unfortunately, like I said, with the primitives thing, we have to make like mirror objects to integrate in Godot. Over here I have the vector2 one. This one is actually a reference. That means It'll be reference counted. It's an object, so it has signals and all that junk, so that we can get this value to exist in GDScript, so we can get this vector2 to exist in the editor and the inspector, all that stuff. And it annoys me to have these two mirror objects. I wish we just had one. And I guess we could. I could decide that I just want this vector object to be the vector object, but it just bothers me. You know, we're doing C++, right? So in C++, like, all the objects don't need to be allocated on the heap. All the objects don't need all this junk attached to them. A vector should just be two integers, man. So we are going to have these sort of external objects and internal objects. And I started on, you know, these nodes, that area 2D node and the collision shape 2D node. And that's all there is, really. Or I guess these editor plugins that I made. So this one is what makes it possible to edit the vector2. It adds the vector2 controls to the inspector. This shape 2D one will eventually be what adds the handles to the shapes and lets us drag them around and stuff. But that's it. So let's start making some more interesting stuff. I want to start simple. I want to start by making just the simplest thing we could possibly make and do some collision detection. And I think what that's going to be is a sprite moving back and forth that when it enters an area, we're going to change its color. Sound simple? Let's do it. So we'll have an area 2D. And I guess let's sort of move it to the middle. Where's my screen size? There's my screen size. And let's add another area 2D, another SG area 2D. Let's put another collision, an SG collision shape on it. We will create our SG rectangle shape 2D. And I guess the other one was 50, so this one is 25 by 1024, so that's 25 pixels, 25 by 1024. And we will move this one down here. We'll rename this one character. This one I guess we'll just call area, something like that. Oh, I made this one an area. Do I want it to be an area? Yeah, I want it to be an area that contains a sprite. That's what I want. And like all Godot demos, we will use. Oh, I actually don't have the Godot icon in here. I'll have to use the retro tank party icon. There. So our little tank will move back and forth. What's going on in chat? Gallo, hey, welcome to the stream. Asks GD native ? No, this is a Godot module, which means that it is compiled directly into the Godot engine. GD native kind of sucks. I don't know if anyone out here develops their games in GD native, but it's a very uncomfortable, annoying environment to work in. It makes sense to do GD native, I think, if you're making a plugin that you want to distribute to lots of people, because then they just drop their, you know, the DLL or whatever into their project and they can use it. But like for my own game, I definitely prefer to write modules. GD native is just weird. You're basically like using the Godot APIs through this like weird C language shim, and not working with the actual like objects. In Godot 4, the new version of GD native, which I think is called GD extension, is going to be basically the same as writing a module. And I'm very much looking forward to that. But I also think that it makes sense to do this as a module for a couple of reasons. In Godot 4 also, it's going to be possible to swap out the physics engine. And if this, you know, fixed point deterministic network physics engine goes well, I could turn it into a, you know, swappable physics engine for Godot 4 maybe, after it has like way more features than I'm planning to do at the moment. So yeah, it's a module rather than GD native. Anyway, let's add a little script to our character. Attach script, we'll just call it character, that's fine. So we're not going to be doing anything with the rollback code at this point. We're just going to like move this thing back and forth. So we're going to do a physics process, I guess. Should we just do normal process? So With our own physics engine, do we still want to use physics process? So half the reason for using physics process is because it allows you to call the normal physics engine from there, which doesn't matter for us. It also gets its own like locked frame rate, which we do want. So maybe we'll just use physics process because we get a locked frame rate. All right. And we want to have some kind of vector. We'll say, I'll just call it vector. And actually, no, let's start it in a particular direction. And we want some kind of counter. And basically what I'm thinking is we'll move the vector in one direction until the counter reaches some value, and then we'll flip it and go the other way. Oh, sorry. Sorry, GD script. All right, there we go. That should make you happy. So we're going to do... Okay, first things first. Let's do this without integrating with the physics engine. Let's do this just straight. We're just going to change the position. We're going to say the position plus equals vector times, I don't know, 400 times delta. Or do we want to deal with delta? I guess we do because we're just thinking about physics. With the rollback stuff, we would not want to deal with delta. And then we'll increment our counter plus equals 1. We'll say if counter is greater than, I don't know, 100. Then we'll say vector equals vector 2. We want to flip it. So I guess, no, we'll say vector equals vector x negated. Right? That makes sense. And then counter equals 0. And I misspelled position. Position. What are you yelling at me about? Vector okay, vector x equals negative vector x. Perfect. All right. Let's see what happens. What? Oh, because I'm doing this stuff here. Let's get rid of this quit. Going to the right. 100 was clearly too many. And then it's coming back over here. Okay. So let's just change that. 100 is too many. We'll do 50. Just try that again real quick. Slacks. GD native unifying the module system with it is a good plan. Yes. Looking forward to the new implementation for GD native and Godot 4 as well. Yes. Yeah. That will be awesome. So many things to look forward to in Godot 4. Okay, so we got our tank bouncing back and forth. I think our area is in between here. It should show visible collision shapes. I put something in the code to do that. We probably need to restart it. Let's just see if that works. I think I put something in the code to do that. And I did, yay! Okay, so that's our area showing its collision shape. And we are not doing anything with the physics engine. All right, so to do this with fixed point math, we have to do all of the math, even in GDScript, with fixed point math. And I'm thinking the flow is going to be like this. Make a new little script here. So we are going to have our, wow, that is a bad square. We're going to have our area, which will have its normal like Godot position stuff on it. But we're also going to have a fixed kind of position on it. Or maybe that's not even the way to think about it. Okay. Let's remove that. So we have our area with our Godot position, which just decides where the thing is displayed. And then we are going to update the object's position in the physics engine. So we're gonna update its position in the physics engine. This will be physics. In all fixed point math, which will then in turn update the Godot object in floating point math, its position in floating point math, so that will control its position on the screen. If we move the object in just by messing with its Godot position, we're going to not have that affect the physics engine. Because we want always, when we're dealing with our fixed point physics, to be doing everything in fixed point and just have the floating point stuff be whatever it's going to be for display purposes. So how will that look? First of all, this vector needs to be a SG fixed vector 2. Or wait, no, we have another tool to make that. We have our vector 2 factory function. And going to the right, that is positive x of 1. So 1024. See how nice it is to put literals as integers. And we're not going to be messing with position. So we need a way to get our fixed position. So we'll need some kind of member like fixed position. And we're going to want to do like plus equals, or we can't do plus equals because we can't use overloaded operators. So fine, okay. I add, that's for in place add, our vector multiplied by, and I think we should not do this 400 delta thing, because we can't do that in rollback anyway. We want to have every frame we move a fixed amount. So let's say every frame we move 5 pixels. And then we do basically the same thing here. We'll have our fixed point vector x equals negative. Yeah, actually it's exactly the same. I just need to change the, yeah, it's the same. Don't need to change anything. Nothing needs to change. So what we need to add to our system is this fixed position thing. So let's head over to C++ and do that. Let me check out chat. Gallo, why are you making network physics system on Godot? I'm sorry, I missed the other 14 streams. No worries, man. No worries. We've been implementing for the last 5 or 6 streams. Hey, Python method name? I don't get your joke, Ricardo. For the last 5 or 6 streams, we've been implementing rollback and prediction, network synchronization, which depends on having deterministic network physics in order to fully work. Like we have it working with Godot's physics engine, but I have like some diagnostic stuff built in to see how far out of sync the different clients are getting. And after a couple of frames, they start drifting out of sync. And you know, with us playing, like there's been loads of bugs and other problems. So like maybe if we fixed all of those, we would notice more that the physics are jank. But we haven't really noticed the physics being out of sync. So like, it's not as big of a problem as like, you know, as people talking about rollback and prediction would seem to make it be, at least in practice. But I don't know. Theoretically, the physics do need to be deterministic for rollback and prediction to correctly work. Oh, Ricardo's saying I add. Yeah, I guess I did take that from Python. Isn't it better to just use server-side physics? So yes, server-side physics is an option if you are building a client-server game. This is a peer-to-peer game, which peer-to-peer using rollback and prediction is super common in competitive fighting games, and also some party games like kind of Smash Brothers style games, which is what Retro Tank Party, the game that we're actually working on, is. So we don't have the option of doing server-side physics. We could sort of do a server-side kind of thing if we picked one of the clients to be the server and had them do all the physics, which, you know, is something I considered. That was one of the things on my list if this new network synchronization technique didn't work out. Because I do, like, my high-level goal is just to make the synchronization better in Retro Tank Party. Because I was working on a new game mode where the current network synchronization technique was lacking. It was a football game mode. And so I'm like, well, I need to make this more accurate. And I decided to try doing rollback and prediction first. And if that failed, I was like, well, maybe I'll just pick one of the clients to be like the server and do kind of a client-server thing. But this has so far been working. And I'm excited to keep working on it. Especially, you know, I'm making some add-ons to make implementing this in Godot games easier, which are going to be in the Godot asset store. And I don't know. I chose to go this way. Hopefully you're interested in going this way with me. Gala, I've never made a peer-to-peer game before, only client-side stuff. Oh, okay, cool. All right, so let's dig into adding this fixed position here. We need to make this really be a thing. So So that would be on our area 2D. So it will need to have, I guess this would be the Godot version of the vector. So let's include that. That is in math. Nope, nope. Do I need to go deeper? Math? There we go. Vector. And I guess it will be a private variable. SG fixed vector 2 fixed vector. Now we need to expose this to Godot. We do that by adding some setters and getters, which I've been doing a lot of those inline. I think I don't need to do it inline because I don't think much is going to be directly accessing that. Well, let's do them inline anyway. Force inline. Maybe the physics engine will. This extra layer of Godot stuff, like to access this low-level type, just like bothers me. No, never mind. We're not doing it inline. Forget it. Forget it. We'll add it inline if it turns out to be useful later. I need to not let like my own hangups about this this extra layer of indirection affect me. Okay, so we need some getters and setters. We'll do void set fixed vector sg fixed vector 2. And we actually want that to be a const reference. P fixed vector. And we need to get it back out. Or wait, hang on. These have to be references. These have to be references. Okay. Ref sg fixed vector 2 get fixed, or not fixed vector, fixed position. Wow. Fixed position, fixed position. Can this be const? I don't think that can actually be const. Okay. So we need to add those accessors. Let's jump to the CPP file, quick implement them. No, this is the wrong one. Area. What's going on in chat? Raphael C. Hey, I'm a bit late. Is he working with Godot source code? Yes, I am working in the Godot source code. This is, I'm making a custom Godot module for our custom mini physics engine. So I added a setter. Here, I'm just going to copy paste this. I don't do a lot of C++ on a daily basis, but man, there's just a lot of typing. There's a lot of typing. Come on, copy and paste. Copy and paste, guys. Okay, there we go. I'm sure there's like some VS Code add-ons that I will start installing at some point to make all of this less typey. Okay, and we are going to do p fixed, or no, fixed position equals p fixed position. And we'll return our fixed position. And then we need to bind this, which I never remember the code for. I always have to copy and paste from like the last time I did it. So let's grab these accessors, just copy them over to our bind function here with our get and set. We'll just change what these are getting and setting. Getting fixed position, set fixed position, I don't know, fixed position? Fixed position, fixed position. I guess I have to change what we're at R2, to D, to D, the property. And it is an object, and then we're going to add a hint which will actually activate the editor plugin that I created to show our vectors in the editor. So property hint, I think it's type string. And if we tell Godot that it is an SG fixed vector 2, that will have this editor plugin find it. I'll just show you that really quick. So we have, this is actually like 3 classes are necessary to make this work. We have our editor plugin, which loads up here and then adds our inspector plugin. And then here is our inspector plugin, which is what will tell a particular, which is what the inspector will use to decide how to create the controls for the property. So we then go to our inspector plugin here, which is this code. And when it's parsing the properties, it's looking for a property with a property hint type string and the hint text of xgFixedVector2, which causes it to create this editor property xgFixedVector2, which is this class up here, which will actually then create the controls, which is actually a lot of code. It will create the controls that go into the inspector. And this, I just copy and pasted it from editor property vector2 and modified it so that it uses our fixed vector to actually load and store the data, and then some changes to how these spin controls were made so that they are using only integer values. So use rounded values. So you can't put a fractional value in there because the spin control normally holds floats or doubles. It holds doubles. All right, so back to our area 2D code, which might be done. Or at least insofar as we added that property. We still need to do some more things to like sync those changes to our underlying physics engine. But let's make sure. No, we are not done. This needs to be fixed position. Fixed position. All right. So this should be enough. What did I type? I typed something. This should be enough to get our property going. I'm just going to build it, see if there's any compile errors, and check out chat. Raphael, hey man. Thanks for coming by. Came for the network physics, stayed for the C++. Yeah, C++ is super repetitive. Slacks, ever looked at Rust? I've looked at Rust. I don't know if that question was for me or for Raphael. But Rust looks really cool. I've done some Project Euler problems in it. It's like, you know, just dumb math problems that are useful for learning new programming languages. And I did like a test project in Godot with Rust, and it's cool. It's really cool. I haven't gotten real into it, and I don't know if I would. Oop, this is opening on the wrong screen because I'm overlooking at chat. I don't even know which terminal it is. Doesn't matter. This is loading up. I don't know if I'd actually do a real project in it though, because like that means I'm basically working with GD native, but in Rust. I don't know. We'll see. With Godot 4, I think the new GD extension is going to make non-scripting languages like C++ and Rust and NIM and all of those like way better to work with in Godot because you'll be able to directly create Godot objects rather than having to deal with like the Godot scripting system. And then maybe I'll do more stuff with Rust and other programming languages, at least in Godot. So what was I working on? I was working on this physics test scene character, and I guess just to see that our property exists. The property doesn't do anything. We need to have updating this property actually change something in the physics engine, or do we want it to do it automatically, or do we want to have like a method where we say sync to physics? I'm not sure. Let's look at how this appears in the editor. Uh-oh. Fatal error? Fatal error? Segmentation fault. I know what I did. I know exactly what I did. This is how you can tell that I don't do C++ very much. I did not allocate the memory for that fixed vector, and that is why we are crashing. Okay, let's get over to our SG area 2D and the constructor. We need to actually allocate the memory for this new variable we put here. Chat, you're supposed to be watching. You're supposed to catch these errors for me. You guys are the backup compiler here. Okay, so yep, mem new sg fixed vector 2. All right. That should cover that. Let's kill our. Ooh, do I have two editors open at the same time? Cancel. Abort. Abort. Reload, I guess. Just whatever will let me quit. I need to quit. And is this our... No, here's a terminal. Okay. And this is our other editor. Oh, I guess because it's segmentation faulted, we need to hit the big red stop button here. Get rid of this editor. That's now covering up chat. And okay. Let's just recompile so that we can know that my mistake was forgetting to allocate the memory. Oh, Raphael's saying the code looks blurry for him. Let me see if I can make the font bigger. It could be your internet connection or it could be my internet connection. Earlier, I was getting like a really low frame rate on the stream. How do I even do that in VS Code? Any VS Code experts out there? I'm not one. Ooh, that's bigger. All right, is that big enough? It might be too big, but let me know. Let me know, chat. I can't even see the bottom of this build. There we go. It's linking now. Okay, so I want to see what this looks like in the editor. I wonder, so what's the workflow in the editor going to look like? When we're in the editor, dragging an object around in the editor will not update our fixed position. It's going to update the Godot position, which when we're in the editor, we do actually want to sync to physics, where normally we don't. So we'll need to add some code for that. And then in the editor, do we want to edit the fixed position? And if we do, what does that mean? All right, here we go. Now I can see the fixed position, which is empty, which is just wrong. Okay, so I think we need to set up like a little bit of syncing between the fixed position and the Godot position. I'm not entirely sure how that should work, but let's figure it out together. Let's figure it out while we code. Awesome. Thanks, Andy K, for letting me know that you can see it good now. Okay, so we've got our fixed position, which when we update it, we probably want to update the underlying object. We have to make the underlying object. That's another thing. And we want the fixed position to get the position from Godot when it's first created and when it's in the editor. No, not when it's first created. Only when it's in the editor. Only when it's in the editor. Because when it's first created in game, we want it to load it from the fixed position. Oh, this is confusing. We want to sync. Okay, so I don't want to end up creating an infinite loop where updating one position updates the other position, which updates the other position. Maybe we just don't expose the fixed position in the editor. Well, let's leave it exposed for now. But how does it get set? Okay. So here, I place this thing here. The Godot position updated, so it should update this. That's what I think we need to do. Then this will get saved. And we're only going to update from the Godot position to this position in the editor. And then when this is loaded up, we need to do the reverse. But how do we not make this into an infinite loop? I mean, we could have like a guard variable that when we're setting the one, we set this variable so we don't loop. But man, this is confusing. I kind of wish that I didn't even put this fixed position on the node and just put it on the underlying object, and then we were dealing with the underlying object. So this object needs to save its fixed position in the scene. So it needs to be here somewhere, because the underlying physics object doesn't exist until created, so it's like not saved in the scene file. But right now we're creating this in the editor, so this needs to get updated. I think we might have to do the guard variable thing. What is chat saying? Oh, Raphael's got to run. I really enjoyed the donut tutorial, the Blender donut tutorial. It is fun. I'm not an artist in any way, so like following tutorials like that is basically all the skills that I can muster. But yeah, that's a good time. Okay, so let's quit out of this so I don't accidentally have two of them running again. And we need to do a notification thing to find out when the Godot position changes. So do switch p what case notification transform changed. How is that different than translation changed? One is from node, one is from canvas item. I wish I knew the answer to that question. Let's bust out the Godot docs and see if there's an answer there. Godot notification translation changed. Godot notifications translation. I just want a big list, guys. Where's the docs with the big list? Notification. Here we go. Well, no. Not here we go. Okay, so that one was on node. Let's go over to node and see if it... Okay, so it has them here. Translation changed. Notification received when translations may have changed. Can be triggered by the user changing... Translation, like language, can be triggered by the user changing the locale. Can be used to respond to language changes. Okay, not translation as in, spatial movement, but translation as in the language. Okay, so transform change is what we want. So when that changes, when we are in the editor, so if, I think it's engine, get singleton, or is editor hint, I think. Come on, autocomplete, help me out here. Oh, is it because we don't have this loaded? Okay. Wait, what? Name must be followed by, but it's like showing the class definition. Oh, come on. Let me type. Singleton. Okay, so it has a get singleton. What was it? Do I have to include something? Jesus. Include core engine.h. Does that make you happy? Okay, cool. And is editor hint a thing? It is. Okay. Whew. Then we want to copy from the normal position to our fixed position. So fixed position, we probably want some method to set the fixed position based on some floating position, because we'll probably do this a lot. Let's go to our fixed position class, our fixed vector 2 class. To float, and then I guess what we want is from float. Yeah, we don't want to have a static function. We want to like overwrite what's currently here with another value. So void from float, which will take a normal vector 2 p float vector, and we'll implement that method here to float. Say void sg fixed vector2 from float vector2 p float vector. And then we need to basically just assign the values. So value dot x equals p float vector x, but we need to convert it using our float, or not float, fixed from float method, and the same thing for y. That should be good. Let's bind it so that we can use it in Godot or in GDScript as well. All right. And let's go back to where we left off over here. Fixed position. Okay, because this is a reference from float. And we need to take the normal position. Which, do we have a position variable at this point? I don't think we do. I think we have a transform. Transform dot position, something like that. All right, I don't remember. Let's look at our base classes here. You're descending from node to D, and let's see what we got. How do we get our transform? Get transform, is that all we get? Do we have access to the underlying data, or is that private? Looks like it's probably private. Let's just look at the implementation of get transform. Returns this underscore mat, which is private. Okay, so we have to do get transform. All right, that's fine. So let's make a little temporary variable. Xform equals get transform, and we'll say xform position translation translate. Oh my god. Again, this is how you can tell I don't do C++ terribly often, because I don't know the names of all the things from the C++ side. Translate scale, but I want to know. Okay, so we can access the matrix directly, which I don't really want to do. Get rotation, scale, basis. Oh, are we looking just for the basis? Origin? Origin, I think. We'll find out. We'll find out when it works or doesn't work. All right, so what this should do is that when we update the position in the editor, it should update our fixed position. Do we need to tell the editor that something has changed in some way so that it will know to update the inspector? I do not know the answer to that question. If anyone in chat does, that'd be awesome. Otherwise, I'm just going to try it and we'll see what happens. So here's what I'm thinking. Once we have our ability to update the area 2D and have it update this fixed position, we're going to sync the fixed position to some underlying area 2D object in our physics engine, which is outside of like the Godot bound code. And then from there, we will actually attempt to detect the collisions, which we have to create the underlying area 2D object, the internal one, because I did not create that before, but it should be simple. All this Godot bound code requires us to do all these extra sort of like accounting things to kind of make them work, whereas the internal like physics code will just be like straight C++, which will be a lot just faster to work with. Come on, debug symbols run so slow. Okay. So let's see if this worked. So we have our character, area 2D. I am hoping that I will drag it. Oops, I'm dragging the wrong thing. But whatever, it's still in area 2D, so it should still have updated. Why did it not? Lame. So the transform position has changed, and this has not changed that. Let's return to the docs. The docs are our friend. Let's check out transform 2D. Let's see what we got. So origin, x, y. Origin must be what we're grabbing. Equivalent to index 2. Origin represents translations. That's what we grabbed. We grabbed translation. Why did that not work, though? Let's go look at our C++ code again. Fix position, from float, export, get origin. I wonder if it's working, but we're just not seeing it working because the editor's not updating. And I'm like forgetting to call some function to make the editor update. How can we determine that? So I go away and I come back. Let's try setting this to some value. Away, come back. I could try saving it. See what gets saved. This is physics test TSCN. So there's some shapes. Where's our area? Position, fixed vector. No, it's still coming out as zeros. Notification, transform, change. We're checking if we are in the editor. We're updating that. You know, another alternative is to just say, forget this automatic update. Let's just set some things manually so we can get down to physics. So what we will do is in our code here, I want this to go back to where we had it previously. We will just manually sync in the onReady function. We will update our fixed position from our normal position in GDScript. And then we're updating it here. And again, in the interest of doing things like manually, we'll say like, we'll add a new method like sync to physics that will copy from Godot's, from the Godot node into the physics engine. And I guess the rest of this, when we actually get to it, will be something like if, we'll say like overlaps area or something. We'll make up a method like that, and if it does, then we'll change the modulate to red. Okay, so in the interest of getting some things working quickly, we're going to add a sync to physics method to just copy the data over. Later, off stream, I'll figure out how to make all this stuff sync with each other automatically, and then add some other method to check if we are overlapping the other area so that we can get to writing some physics code. All right, so we will add those methods. Where is the header file? So that was a sync to physics method and a bool overlaps area method. And we'll start the implementation of those over here. Void sg area to d, sync to physics, and a bool sg area to d, overlaps area. Cool. now we need to actually create the underlying physics object. So everything in this internal directory, I'm kind of treating like the physics engine itself. And all we have right now is a shape base class and a rectangle class. We need to add like bodies of some kind. So let's make a new header file to hold those. It'll be like bodies. Just seems weird to write the word bodies like we're hiding bodies in the forest or something. Yeah, I guess we did shapes. We're gonna call it bodies. Bodies 2D internal, and get our boilerplate in there. I think I screwed up that copy. Little copyright notice here. And we are going to define a class, which will be SG area 2D internal. And an internal area 2D, what does it need to hold? It needs to hold some shapes. So we'll do like one of Godot's vectors. I forget. Let's look. Vector H. So I think just a plain vector is what we want. Yeah. Plain vector in this header file. Let's get back to where we were. What? I was trying to get to the show all button and I did close all. All right, internal here. We're going to include the header file with the vector. That was core vector, yep. We're gonna make a vector of our SG shapes, which is gonna include the header for that. SG shapes 2D internal. SG shape 2D internal. And do we want to hold the actual objects or pointers to the objects? C++ decisions that you have to make. I think we want to hold pointers. Well, they're very small objects. Okay, so for people who don't do C++ a lot, I don't do C++ a lot either, but the decision between pointers or not pointers, if they're pointers and we add a new item to the vector, it creates a new vector that's bigger and then copies those pointers over. If they're not pointers, it has to copy all of the actual data of the objects, which if you have big objects will take a lot more memory than you might think it does. Like, oh, I just got a list of things, but if each of the things is 100 bytes or something, that could be a problem. But also having them be in memory in a row like that also is really good for the CPU cache. So it's a tricky decision. I think because all of these shapes are very small, maybe it makes sense to not have pointers, because like we have a position and an extent to make a rectangle, and since we're going to be looping over them, or maybe it doesn't matter because most objects only have like one shape anyway, and then I'm just sitting here worrying about a decision that makes no difference. I don't know. We will start with them not, or maybe do we have to have them? I think we have to have them as pointers, actually, now that I'm thinking about this, because these internal shape objects also need to exist inside of Godot RIDs. Okay, so they have to be pointers, I think. We'll find out. So shapes, and we'll need some public methods, void add shape, so SG shape 2D internal, or hey, maybe we could just start by saying it only has one shape, for simplicity. I don't know. Let's stick with what we've started. We'll add a shape, P shape, and we will remove a shape, G shape 2D internal, P shape, All right, so this is the internal version of our area 2D, which is going to have a rectangle shape added to it. Let's implement some of these methods. Bodies 2D, internal, CPP. And let's implement these. I'll copy and paste them over to slightly reduce the amount of C++ typing that I have to do. And SG area 2D internal. SG area 2D internal. Include the header. SG bodies 2D internal. Oh, and I just realized I forgot another very C++y thing to do here, which is the if-in-def. If-in-def SG bodies 2D internal H. Okay, how are we doing on time? Oh, geez, 11:41. I'm sorry, guys. I did not fully appreciate how low velocity writing C++ code is. Let me know. Let me know if doing C++ like this is interesting on the stream or not. Because just everything takes so long to do. Like in GDScript, I can just like write a bunch of lines and we're already like doing stuff. Okay. Let's get to the point where our physics engine can create these and do things with them. So the physics 2D, SG physics 2D server here is kind of acting like the interface to our physics engine. In a very Godot way, we're creating a server, which is just kind of like a class that manages some objects that it doesn't actually give you access to. It's used for the renderer, for physics, for all sorts of things in Godot. I guess area 2D. This should actually be like body. Yeah, I don't feel like making the base class right now though, so we're just gonna say area owner. Area 2D internal. And we need a way to create the underlying area. Create area. I don't think we need to pass in any arguments, right? Well, I guess it needs a position. So int x, int y. Need to include bodies as well. And then we need some sort of like void area add shape. RIDP shape. And then we need, it should actually be area overlaps. And we should just check if it overlaps any other area. And it's not a shape, it needs to be an area. Okay, so I think those are the methods we need here to make this work. Create an area, create a rectangle shape, add the shape, check if it overlaps. Yeah. We'll implement that over here. This method no longer makes sense. I'll just comment out this code. It might be useful later. It does a really simple like rectangle overlapping thing rather than having to retype that. Create rectangle shape, RID SG physics 2D server, create area. Chat has gotten very quiet. Have I totally bored you all to death with typing C++ code? Please let me know. Okay, so we're creating our internal object. And new SG area 2D internal. Area, we didn't put any setters on it. Oh wait, hang on. I'm doing this really weird. Do we want to have an area in the physics engine? Like currently the physics engine just has shapes, and maybe that's fine. So we create a rectangle shape in the physics engine, which has a position and an extents, and that could be attached. Is there a way I could write less code and still get something done in the next 15 minutes? I think in the end we do want to have areas in the internal physics engine. I think we do. But like right now, the areas have positions, or the shapes like are their own independent thing. Maybe areas don't need position. Maybe areas just need shapes. Let's run on that kind of assumption. Areas don't need positions. We'll just do RID, ID, area, owner, make RID, area, return ID. All right, so areas are a thing that have shapes, but they don't have any position information. The position information is actually on the shapes themselves, which I think is fine. I think that's fine. And we say area shape overlaps. We also need to keep an idea of all of the areas, which I guess we do, right? We have that on RID owner here. I think we can, from this, get a list of all of the areas. It has a immutable set. Get the RID. Can we enumerate them? Owns has free get owned list. That only returns something when in debug mode. Okay, maybe we do need to also store them on some kind of list beyond keeping them here. Andy K, don't know about anyone else in chat, but C++ makes me feel dumb. I'm sorry, dude. I don't want to make anyone feel dumb. So I chose to do this in C++. Because I feel like doing it in GDScript would be too slow. Maybe it would work. I don't know. When you're doing a lot of math-heavy stuff, C++ seems a good way to go. Another alternative would be doing it in C#. And I do like C#. Every time I'm writing C#, I feel good about writing C#, whereas writing C++ like largely makes me frustrated and makes me feel like I'm typing too much. But like my game doesn't use C# at all right now, so just adding it to do physics seems odd. Whereas C++ means like just my binary gets some number of bytes bigger. Also, like if I want to make this be reusable someday, which would be nice, I don't know if we'll get to that point. But in C++ means you know, people who are using C# or not C# or Rust or whatever will be able to use it without adding like an extra runtime. And then also like if I do want to make this into a physics engine you can drop into Godot for, like then it has to be written in C++. I don't know. But if it makes for bad streaming, maybe I'll stop doing it on stream. Okay, so we need a way to have a list of all of our areas. Andy K, you don't need to know C++ to be a real programmer. Lots of real programmers don't know C++. That's okay. We need to get a list of all of our areas so we can see if they overlap. So where will we store this list of areas? This won't store them for us. Do we want to have another internal object to store all of our areas? I feel like that's the right thing to do. I don't know if we want to do it on stream. For now, for stream sake, we'll throw a vector on here that holds all of our areas. And those will be pointers. We'll call it temp areas, so I know that I'm removing it later. And we gotta, I think, include the vector code unless we get it already from object. Looks like we do. Okay, so when we create an area, we also need to add it to our temp areas, push back, area. And we create a rectangle. We need to implement our add area, add shape. Where's our physics server? Void sg physics 2D server. Was area add shape, and we took the RID of the area, or I'm sorry, of the area, and then the RID of the shape. Unless I did that weird here. I did do that weird and wrong. RID of the shape. First argument is the area. All right, so we need to get the SG area 2D internal area equals P area get data. And we need SG shape 2D internal shape equals P shape get data. And we just need to add it. Area add shape shape. And our overlaps thing, what are you complaining at me about here? Data cannot be used to initialize a type. What do I gotta do to get the data out? I forget how I get the data out of there. So data gives me RID data. Do I just cast it? I'm just gonna cast it. Bodies internal physics server. I'm just gonna cast it. Do static cast SG area 2D internal. Why not? Why static cast? Won't work. Invalid type conversion. Oh, because it needs to descend from RID data. Okay, I got this. Thank you, static cast. That was actually very helpful. Bodies internal, this needs to Are we happy now? Beautiful. It's happy now. Okay. We have added a shape, I think. Or I typed area 2D again. I meant to type shape 2D. And now we've added a shape. All right. So let's go into our area 2D and make adding a shape actually do something. Shapes, push back, P shape. And we're not actually going to clean up after ourselves because who has time for that? Do we have erase? Or shapes? We have erase, right? C++? We do. Shape. And the last bit that we need to make anything actually happen is add some sort of overlaps area method where we take another SG area 2D internal, other area, and we are going to check that if all of the shapes overlap or not. Or if any of the shapes overlap, I guess I should say. SG area 2D internal, overlaps area, SG shape 2D internal. Okay, and then this will just be some looping. Why? What's your complaint? Incompatible with bool overlaps. Oh, because I typed shape. Okay. So, I always forget how to do iterators in Godot land, but it's like vector, sg, shape, 2D internal, thing, element? No? Okay, let's find some code to look at to steal this from. Or maybe just look in the vector class itself. It's like element something. Or we can look for a for loop. No, 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 no. Or maybe I'm not thinking of vectors, maybe I'm thinking of a different data type. We can just loop over it by index. Then shapes size. There we go. Old school C-style for loop. So what we want to do, or we'll do not I, or I guess, yeah, we'll do I and j. I, j. What we're going to do is we're going to loop over both arrays of shapes. And we're going to check if any of them overlap. So if shapes I, and what is the method called on those shapes? Why can't I access this? Oh, because it's a pointer. All right, so sg internal shape. Gallo is back from lunch. I'm not sure you missed anything hugely exciting, Gallo. Oh, there's a bunch more chat. Zero Wolf. Zero Wolf has a very basic knowledge of C++, not a programmer either, so it's like a necessary evil I had to learn. Slacks. Been a long while since I touched any C++. Suspect I'm more than a little rusty. Ricardo, I think ... element is right. Cool, I wasn't just talking gibberish. They also just merged a PR where iteration was made easier. Oh, cool. I did not see that PR. I on a pseudo regular basis, like every day or every other day, I go look at like what was recently merged in the Godot repo and just kind of read through there so I can keep abreast of everything. Oh yeah, for list. And maybe list is even the right thing to use here, because list is a doubly linked list, right? That would mean we're not reallocating anything when we're iterating shapes, but then we don't get the CPU cache advantages. I don't know. Data types. C++ is like all data types, man. All right, how much time we have? We have like 2 minutes. Can we get anything that works in 2 minutes? Probably not. Probably not. Oh my gosh, guys. Although I learned C++ in college and made my own GD native plugins, but never made a module. You should try making a module, Gallo, because it is a lot friendlier for the developer than making a GD native plugin. So guys, as seems to be like a pattern for the stream, I thought like by getting all of that boilerplate ready, like we would be able to accomplish something today. We didn't accomplish very much on the stream, but we did have fun. I hope I had fun. Did you have fun? Basically, like where this is going is just synchronizing these internal like physics objects with the Godot objects in the editor, and then doing, you know, simple collision checks on them and getting all of that kind of aligned. And I think probably by next stream I'll have that working to some limited degree. You know, right now this is just doing rectangles, or not really rectangles. It's actually just doing AABBs, axis aligned bounding boxes, because they can't turn. Yeah, we're actually going to have to implement our own fixed point version of matrices to do matrix math in order to rotate the rectangles. Or at least I think we will. I'm imagining that the way we will do the rectangle collision is by like taking, when you're comparing two rectangles, to rotate them such that one rectangle is axis aligned and the other one is not, and then comparing from that one to the other one. And to do that rotation, we'll need fixed point matrices. There's a lot to do. I want to get rectangles. I want to get rays. I want to have ray casting in there. I want to have, unfortunately, we might have to do polygons because the tank in Retro Tank Party in version 1.1, I switched from a rectangle to a polygon, and now I'm really mad at myself because a rectangle would be so much easier to do. It is a polygon. Check that out. Which I ended up doing in the version 1.1 because I was getting annoyed by like how off like you would hit the corner of something and it wouldn't look right. Maybe I will even just go back to a rectangle. Maybe no one will notice. Between version 1.1 and 1.2, it just had this brief moment where collision was a little bit different. But yeah, as we get deeper into this, and more of the pieces, the individual like pieces of this are more connected up, hopefully it will get more interesting on stream. Maybe next week we'll try doing this again, and if it's not overly boring. Oh, and I should say next week, I'm not going to be able to stream at the normal time because my girls are going to be in swim lessons, and I need to go do that with them. So I'm thinking about pushing it like 2 hours later, maybe starting at noon CDT rather than 10 CDT. I don't know. I will announce it later in the week. But here, let me just write this last piece of code. We'll have one piece of code to close us out here. What is the collision check code? Oh, I actually had that in the server, not there. Okay, so I can't even write this last piece of code. We don't have enough stuff written here to write the last piece of code. What we need is a shapes method, which is like overlaps shape, or overlaps overlaps shape. We need like a virtual bool overlaps shape kind of thing, and to implement that. More code than I could write in 0 minutes. Well, anyway, thanks so much for watching. Double extra thanks to everyone who helped playtest in the beginning. That was super helpful to get a feel more for the latency and how it reacts to real internet conditions. I will see if I can dream up some possible solutions to the problems that we experienced this time. And yeah, thanks again. Hope to see you guys next time. Bye-bye.